Now, we've looked at a number of different applications for our 4-bar mechanism, from lifting, pushing, walking, and every instant it relies on this crank mechanism, this red link here, that has a motor attached to turn this continually. But I noticed after making certain changes to this 4-bar mechanism, the crank wouldn't turn. It would get to a certain point and then it would stop. So let's take a look at what's actually happening here. In kinematics, this is an example of Grashof criterion or Grashof law. And Grashof's criterion basically helps predict whether one part can or cannot rotate continuously. So let's take a look at what decides whether this crank will actually turn or it gets stuck. Now, I've renamed these links S for shortest, L for longest, P and Q. Now, if I go and try to turn this, we see this jams. And the law states that if L plus P, which is 120, is shorter than S plus Q, which is 130, this won't work. And you can see why. As we try to turn this, it just doesn't stretch long enough. This needs to obviously be longer to get this crank to turn here. Another problem is if S plus L is greater than P plus Q. Look what happens here. If we go and try to turn this, you'll see it jams also. So that's another one to watch out for. Again, S plus L can't be greater than Q plus P. And this is what's called a triple rocker mechanism. Now, what if this fixed link was the shortest link? Would you expect this still to turn if we tried to use this as the crank still and turn this? Would it still work? Well, actually, yeah, the crank still turns. But you don't just have one cranking 360 degrees, you have two. Both these are basically like cranks. So when we turn this, you have the crank, but there's no rocker. It's just two cranks. So they call this a double crank mechanism. Now, what happens if we make the crank and the rocker equal? Let's just change this to 40 also. And L and Q are also the same. Will this still turn? Yeah, so basically what we have is a parallelogram. But what's happening here, when it gets down here, close to a straight line, this could keep going around in that direction, or it could flip and go backwards like it's doing right there. So you really don't know what's going to happen, and this is called an inversion. It could either be a crank rocker or double crank. So basically the output becomes indeterminate. The linkage may assume either a double rocker crank configuration or a crank rocker configuration.